Hello and welcome to the first in a series of videos that I'll be doing reviewing the SMO Junior mock paper which I had released sometime last week. Of course, this mock paper is a bit different from what we did last year, which was going through the 2020 and 2021 actual papers. And so I would suggest for those of you who have not yet attempted the mock paper, please download it from the link in the description below and try it out first before watching this video. I think that will give you the greatest amount of benefit, especially if you're watching this just before the actual competition. So for this video, I'll just be doing the first 5 questions and we will try to split it up into small chunks like these so that it is a little easier to digest. The good thing about going through a mock paper which I had written instead of, say, just a set of problems from a past year SMO is that I can also share a little bit of insights into what I was thinking when setting the problem, and so you get kind of a behind the scenes look at what a problem setter is thinking when they set such a problem, and maybe that also gives you a way of thinking about how to come up with the solution on your own. Without further ado, let's jump straight into the first problem. We're asked to basically compare A, B, and C, which are these fractions with a numerator of 1 and a denominator which is a power. If you have seen many of the recent SMO problems, this should look kind of familiar, except that there is a 1 over something, and essentially that was just a little bit of a tiny twist which I introduced. It is also not a very difficult twist because really you can just go back to comparing the 3 denominators. 2 to the 25, 3 to the 15, and 5 to the 10. Now, how do we compare these is pretty standard because all the powers are multiples of 5. So we can take the 5th root of everything, which is another way of saying divide all the powers by 5. You have 2 to the 5, 3 cubed, and 5 squared. Now, these are of course very small, so now we can calculate them. This is 32, 27, and 25 respectively. So that means that these are in descending order, and if these are in descending order, when you take their reciprocals, then the order is reversed. So the answer is option A. For the second problem, this is a classic example of how you would introduce the year number into the problem. This is the Olympiad tradition where, in this case, the year 2022 will always show up in an indiscriminately large number of places. So n is a positive integer such that the sum of its digits is 2022, and we're asked which of the following statements cannot be true. And the options are n is a multiple of 2021, 2022, 2023, 2024, and 2025. Now you might imagine that it is quite difficult to come up with a specific number whose sum of digits is 2022 and is divisible by a few of these options. And this is positioned at question 2, which means most likely there should be a simple solution. Also, we note that they didn't actually ask us to find a method to find n, they just asked us which cannot be true. And so if we are asked which of these cannot be true, there should be a simple reason that one of these cannot be true. And if n is a multiple of all these big numbers, it probably means that underlying it there is some sort of a divisibility test that we are looking for. And the divisibility test must be to do with the sum of the digits. As we are aware, the tests that use sum of digits are 3 or 9, and 2022 is divisible by 3 but not 9 because the sum of digits is 6. Now, in view of this, we can look at these 5 options and we realize that 2025 is divisible by 9. That means that if n is a multiple of 2025, it should be divisible by 9. But if n is divisible by 9, then the sum of digits should be divisible by 9, which is clearly not true. And so therefore, E is the one that does not work. Do not worry too much about how you can make multiples of 2021, 2022, 2023, and 2024. I can assure you that it can be done, but that is not such an easy task. So let's just move on from here. For question 3, a straight line is drawn between opposite corners of a 2022 by 2028 grid. How many 1 by 1 squares would the line pass through? And we are given the example where for a 2 by 4 grid, the line passes through these 4 squares. Obviously, 2022 by 2028 is not something that we can reasonably attempt to draw. At the same time, there should be some aspect of this that makes it quite easy to calculate. Whether or not we can find that is going to be at the heart of this question. Now we can look at the example, which sometimes when an example is given, it is deliberately there to sort of plant a small idea in your head, even though it just looks like it is there as an explanation of what's going on. Now we notice in this example that really there are just 2 smaller 1 by 2 grids or 1 by 2 rectangles that the diagonal is passing through 1 by 1. That means that there are 2 squares and then another 2 squares. This might sound pretty silly to say when we are doing it for 2 by 4 because that's small enough. But for something like a 2022 by 2028, at least that will allow us to try to shrink it down a little bit. Now it's not too difficult to see that the highest common factor of 2022 and 2028 is 6, since after all, they are both divisible by 2, and as we have seen in the previous question, the sum of digits for both of them is also divisible by 3. And also the difference of these 2 numbers is 6, so we can stop looking for any bigger common factor because that simply cannot happen. Now, do try to also be familiar with the factorization of 2022, which is 2 times 3 times 337. And naturally, this is the next multiple of 6, so it is 6 times 338. In other words, just like our example here, they are kind of just 6 smaller rectangles of size 337 by 338. Now you might still wonder, well, how are we supposed to easily do something like that, since after all this is a pretty inconvenient size. 337 by 338 is not the most friendly to draw out. But all the same, even though it is not the most friendly thing to draw out, we see that these 2 are consecutive numbers. So maybe there is some kind of a pattern that we can observe by drawing smaller versions of this figure. So we can start with something like a 2 by 3 and do our best to look for a pattern. So if we drew a diagonal for a 2 by 3, you can see that there are these 4 squares that it passes through. And let's draw a 3 by 4 as well. Now remember, when drawing all this, you don't really need to use a ruler and draw it to scale. It just needs to be reasonable enough that you don't end up counting completely the wrong number of squares. That would be pretty catastrophic. So if you drew it through here, you would see that the squares are like this. And the pattern does continue, that it goes through in this sort of a snake pattern all the way down, and that corresponds to 2 squares in each row, where the row, in this case there are 2 rows, there are 3 rows, and for what we have here, it would be 337 rows. So following the pattern, we would expect that there are 337 times 2 squares that it passes through, and then multiply by 6 again. Now remember that 6 times 337 is already 2022, so we don't really need to redo that multiplication, and the answer is 4044, option B. Question 4. Suppose that xy are real numbers such that x squared plus xy plus y squared equals to 340 and 1 over x plus 1 over y equals to 1/3. Determine the largest possible value of x squared y plus xy squared. Take note that whenever there are such problems, you are not necessarily supposed to find out x and y. Now, this is one of the common pitfalls that we have, because for many of us, we are really used to questions that say find x, find y, find z, find a, find b, find theta, and so on. So we kind of imagine that anytime when there is a bunch of equations, we are supposed to find everything, which may not always be true. In this case here, it is not very obvious how you would find x and y anyway, and indeed you are not supposed to. Another thing which we sometimes do is try to use the given equations and do a little bit of mathematical alchemy. Means just multiply them, add them, square it, subtract them, do something to get the thing that we are asked to find. Again, that does not seem that it is going to be a very successful strategy in this case, for the simple reason that x squared y plus xy squared and the two expressions there don't appear to have a very simple relation. But let's try to see what we can do to simplify some of these. Now, first of all, 1 over x plus 1 over y, the fraction seems kind of out of place. And if we add these two fractions, it actually gives you x plus y over xy equals to 1/3. You may also realize that the expression we are supposed to find the largest possible value of is xy times x plus y, because xy is a common factor of the two terms. So that means that, in a way, xy and x plus y are the two main characters in this problem. Not x and y per se, but their product and sum. So accordingly, let's call these a and b. So the product we will call a, the sum we will call b. This means that b over a is 1/3, so a is equal to 3 times of b. We've got one more equation, x squared plus xy plus y squared equals to 340. You can see the xy there, but remember, when you're doing a substitution, you want to make the substitution complete. You don't want to do a half-hearted substitution where there's still a little bit of x and y and a and b. Now there's just too many variables going around. So in order to get x squared plus xy plus y squared, we need to get the x squared and y squared somehow. And so what we will do is to write it as b squared. Remember, x plus y squared is x squared plus 2xy plus y squared. So if I subtract off one copy of xy, which is A, I get 340. So this is great news because now I have got A equals to 3B. I can substitute that into here and I've got myself a quadratic equation. Now, common sense tells you that if the answer is going to be nice, then it surely has to be B is an integer. In other words, this is factorizable. And it turns out that indeed it is factorizable, since 340, the most obvious factors would be things like 10 and 20, and actually that turns out to be what works. So B can be 20 or negative 17. A would be 3 times of this. And so you have two possibilities for the largest value of A times B, but the nicer one turns out to be larger. So that's convenient for us since we don't need to do any multiplication. That is too frustrating. 20 times 60 is 1200 will be our answer. Okay, last up, we'll look at question 5. Now, if a number of you felt that this was a pretty difficult question, you would be absolutely right. And the reason is that traditionally, the SMO tends to have an increasing order of difficulty within the MCQ questions and an increasing order of difficulty within the short questions, but not necessarily across the two sections. So you can have many times where questions 4 and 5 are pretty difficult and then question 6 becomes very easy again. And that's precisely what I think has happened in a few years of the SMO, and likewise down here. This is not an easy question. Now let's put all the information down first. D is on the side BC such that AD bisects angle BAC. That means that these two angles are equal. Let M be the midpoint of AD. So here we are, we have equal lengths. And E is the foot of the perpendicular from M to AB, right? So that means that this is a right angle. Suppose that AC equals to 15, AE equals to 5, and CD equals to 8. Determine the length of AD. This seems to be oddly difficult because there is actually nothing that we can calculate, right? We have no specific obvious starting points. Now in such a case, we kind of need to appreciate the useless looking information a bit more, which is the angle bisector, the right angle, and the midpoint, which all seem to be all over the place. Now one thing about angle bisectors is that they don't just give you equal angles as in definition, but the angle bisector is actually made up of all the points which have the same distance to the two sides of your angle. And that makes it usually one of the things that we would like to add into the diagram when you see something like EM. Because EM here is actually the distance from M to AB. So we can do the same thing to the other side. These two would be congruent triangles, the distances would be the same, and that is equal to 5 as well. Now when we see midpoints, right, we haven't used that yet. Midpoints tend to be something that we associate with either area or the midpoint theorem at the SMO Junior level. And indeed, okay, I'll just erase that 15 for short ball. The midpoint would be well served if we draw another one down here on both sides, so that by the midpoint theorem, these would also be fine. That means that this length down here is also 5. note down, because that is 15. And this seems like a rather interesting coincidence. Well, there are some interesting things that we can actually say here. But at this point, we already have enough information to solve the problem. The reason is that by drawing that in, using Pythagoras, this length is going to be square root of 39. And we're supposed to find AD. So to find AD, we use Pythagoras on the other side. So square root of 10 squared plus square root of 39 squared, which I will just write as 39. And so you get square root of 139. So as you can see, in order to make sure that this question is only solvable by the intended method, I've made it such that all the options here are pretty close to one another. So all the options here are actually between 10 and 12, and the diagram is not perfectly to scale. So if you had tried to do an accurate drawing or measure it, it wouldn't work out that well. Having said that, there are problems where the options are tragically far from each other and it is very possible to guess the answer. So do look out for that in case those problems for geometry are difficult to answer but may turn out to be really easy to guess. Alright, so that's all for this first video. Hope that these first 5 problems are clear enough. Do look out for the rest of the videos coming up for the remaining problems. And again, if you just watched this video and you feel that I would like to try the rest of the questions on my own, please do that before looking at the rest of the 20 problems. So thanks for watching. Please subscribe to support this channel, and I'll see you again in the next video.